My name is Aiman Iskandar bin Muhammad Nizam. My student ID 2025-818-776.
Hi, my name is Nur Sofia Amalin binti Muhammad Syamsuddin. My student ID is 20254666622.
And hello, my name is Nur Awisha Umirah binti Narawi and my ID student is 2025812662.
The definition of redox reaction. A redox reaction is a chemical process where one substance loses electrons and another gains them. This means oxidation and reduction happen at the same time, transferring electrons between molecules. Understanding oxidation and reduction. What is oxidation and reduction? Oxidation is when a substance loses electrons in a chemical reaction. This often happens when something reacts with oxygen. For example is, when iron reacts with oxygen, it forms rust. This process called oxidation. Reduction is the opposite of oxidation. It happens when a substance gains electrons. In chemical reactions, oxidation and reduction always occur together.
Examples of redox reaction in daily life.
Redox reactions are happening all around us every day.
Let's look at some of familiar phenomena in our daily life.
Number 1. Rusting of iron. When iron reacts with oxygen and water, it forms rust.
Example number 2 is photosynthesis. Plants use sunlight to convert carbon dioxide and water into glucose and oxygen. This process involves both oxidation and reduction.
Number 3. Respiration. Our body uses oxygen to convert food into energy, releasing carbon dioxide and water.
Number 4. Combustion. Burning wood, gasoline or even candle involve redox reaction between fuel and oxygen.
Number 5. Bleaching. Household bleach removes stains through oxidation reactions with color substance.
Example number 6 is batteries. Every day, batteries generate electricity through redox reaction between chemicals inside.
That is some example of redox reaction in our daily life.
Next time, if you see rust or used battery, remember, the signs are working.
Understanding LEO and GER in redox reaction. LEO means lose electron is oxidation and GER means gain electron is reduction. Identify oxidizing and reducing agents. An oxidizing agent is a substance that gains electron in a chemical reaction. And a reducing agent is a substance that loses electron and causes another substance to gain them. The oxidizing agent is reduced because it gains electrons and the reducing agent is oxidized because it loses electrons. Always follow the flow of electrons to identify each agent.
Next, we will explain redox reaction in oxygen transfer.
Redox reaction involves the transfer of oxygen.
Here we will focus on how oxygen moves during this reaction. Let's look at iron oxide reacting with carbon monoxide. Iron oxide loses oxygen, becoming oxidized. Carbon monoxide gains oxygen, so it is reduced. Oxidation as oxygen gain and reduction as oxygen loss. Arrow shows oxygen moving from iron oxide to carbon monoxide. The direction in the image helps you visualize the transfer clearly.
Second, redox reaction of hydrogen transfer.
For example, in the reaction of ammonia with bromine, ammonia loses hydrogen undergoing oxidation. Simultaneously, bromine gains hydrogen undergoing reduction. In the ammonia molecule, the hydrogen oxidation number decreases from 6 to 0, determined as oxidation. In bromine, the hydrogen oxidation number increased from 0 to 6, determined as reduction. This transfer of hydrogen atoms is key to understanding oxidation and reduction process.
Number 3. Redox reaction of electron transfer.
Let's explore how electrons move during chemical reaction.
For example, magnesium and oxygen.
Magnesium atoms have electrons that they can donate to oxygen. Oxygen atoms want to gain electrons. When magnesium reacts with oxygen, magnesium donates 2 electrons to oxygen. This forms magnesium oxide or MgO. Oxidation is when an atom loses electrons. Here, magnesium is oxidized. Reduction is when an atom gains electrons. Oxygen is reduced in this reaction. This is how electron transfer creates new substance.
Last but not least, redox reaction of change in oxidation number.
These changes show how electrons are transferred between atoms. Let's look at sodium reacting with bromine. Sodium starts with an oxidation number of 0. When it reacts, sodium gains 1 electron. This oxidation number goes from 0 to +1. This is oxidation. Bromine starts with an oxidation number of 0. Each bromine atom loses 1 electron. Each oxidation number goes from 0 to -1. This is reduction. The final product is sodium bromide, where sodium is +1 and bromine is -1.
Next, balancing redox reaction in acidic medium. Let's look at how to balance a redox reaction in acidic medium step by step. Number 1. Determine oxidation numbers to all elements in the reaction. Second, write the oxidation half fraction and the reduction half fraction separately. After that, balance all elements except hydrogen and oxygen in each half fraction. Next, you need to balance oxygen by adding H2O molecules as needed. You also need to balance hydrogen by adding H+ ions to each half reaction. Then, balance the charge by adding electrons to one side of each half reaction. Number 3. Multiply the half fraction if necessary to equalize electron transfer. Number 4. Add the two half fractions together and cancel out anything that appears on both sides. Number 5. Check that atoms and charge are balanced in the final equation. If everything matches, you have successfully balanced the redox reaction in acidic medium. Next, let's move on to balancing redox reaction in basic medium. Balancing redox reaction in basic solutions can seem tricky, but with a clear method, it will become straightforward. Let's break down the process step by step. First, write the unbalanced redox equation. Second, separate the reaction into two half fractions, oxidation and reduction. Third, balance oxygen by adding H2O molecules to the side that needs oxygen. Number 4, since the reaction is in basic medium, add OH- ions to both sides to neutralize H+ ion. Number 5, multiply half fractions by appropriate factors if needed. Lastly, add the half fractions together and cancel out substance that appears on both sides. Always check your final answer for balanced atoms and charge. Remember, in basic medium, use OH- to neutralize H+. Practice makes perfect when balancing redox reaction.
Thank you for joining us today.
We truly appreciate your time and attention.
We hope you found this presentation helpful and inspiring. Bye!